Hi everybody. This lesson is a little bit of math and science kind of combined here. I use this lesson with my 8th grade STEM enrichment, but I've also done it with 5th through 8th grade at all levels. It can be a simple introduction to the scientific method for data collection and analysis. It can be used for a lot of things, and the complexity really varies. I myself am an aviation enthusiast, and so any opportunity I get to actually make paper airplanes in class for real is kind of fun. So for this project, we used airplane designs from foldandfly.com. You can see up here. We picked the easy category and no scissors, so no cutting or anything else, just a sheet of paper to make each of these planes. Chose this in the easy format because not everyone had ever made an airplane before, and these are easy step-by-step directions. So we can click on one and show you. It just goes picture by picture, matching everything, and there's even a little video on how to do it. Okay? So I had the students pick one of the 5 aircraft available: the basic, the dart, the stable, the waterplane, or the tailspin. What I didn't point out totally is that the stable, the waterplane, and the tailspin are all acrobatic planes. Okay? So they have good time aloft to give kind of thing. So the dart is good for distance, the basic is good for time aloft. Now I told them ahead of time we were looking for flight distance is what we were going to be measuring. So it was up to them to make sure that we were selecting those things. So once they selected their design, I gave them 2 papers, and it just happened to work out recently with my class that I had enough for 3 kids on each design. So I had 15 students in class. Technically I had 14, I was the 15th. So we did that. We have 2 papers. The first paper is to practice the design and practice making the plane and flying it, seeing how it works. The second paper was to refine their work and do as near perfect of a job as they could so that we could compete with them. Once they decided their design, they built them, we gathered a piece of masking tape, put that down the floor as our throwing line, grabbed my 50-foot tape measure, and each student had note cards, and we made a little data table for flight 1 through 5, so they write down how many inches their flights lasted. Our tape measure is in inches, and that offers an extra opportunity later on to convert inches into feet, or an extra little incorporation of math. So once they do that, we all collect their data in their 5 flights. Looking at the data table here, I have separated out. So I actually shared this with the students through the Office 365, and we were able to do this. I'm sure Google Forms can be shared as well. But it shared this, and so the students, they took basic 1, 2, 3, dart 1, 2, 3, stable 1, 2, 3, waterplane, and tailspin. So we just said, okay, you're 1, you're 2, you're 3. Whoever the 3 people were that did that, and they just wrote that number on their plane so that we knew. They recorded their information on their note cards, and then once they were done with their 5 flights, they came in, found their spot on the data table, and filled in their flight data. Now, a couple of them tried to do the shortcut and do the formula for average, but it was a good time to review, as I'd found out, especially from 8th graders, they hadn't had to average in a long time, so some were a little fuzzy. For the younger kids, 5th and 6th grade, have done this. This is a good time to introduce averaging or to review it from math that they had done just recently. So I always try to work this in with the math teacher to coordinate that. So I have their averages from each of them. Now for the older kids, what we do is we also have them then find that average in inches. This is all inches here, and we have them take that to feet. So they take their average divided by 12, gives us our average feet. Now what we have the students do then is they can all see this information. We set up their planes around the room, so all the basics are by each other, the darts are by each other, stables, waterplanes, tailspins, etc. And what they do is they have this data, and they walk around and they look at, okay, so with the basics, for example, basic 1 went 11.76 feet on average, basic 2 is 11.54, and basic was 10.15. So they can look at these planes and realize, okay, these 2 are fairly close to each other, but they're, about 3 inches difference total. That's pretty close. But the basic 3 was a little bit short. Or if you look at the darts, dart 1 went 3 feet longer on average than the other 2. So you can look at how did that person build their plane, did they crease their edges better, was it folded straighter, are the wings different sizes, same size, anything like that they did. So we do that for each category, kind of make some observations about how they could be changed differently or why they were different and performed differently. They all had to throw relatively the same way. We tried to control that variable, how they were thrown, by having to stand toes up to the throwing line, but sometimes you know how you release and all that makes a difference, and the design of the planes are different as well. So between the sets of designs. Once we had done that, we discussed in class and shared that. But then we wanted to make this more visual because they're saying it's still kind of hard to see with the numbers. So we use this as a chance to introduce graphing and how to do the graphing on the computer, a little technology component. So what we had them do was take the plane column and we would copy that and paste it over here to the side. And then we also took the average feet column because those numbers, the feet numbers, are a bit more manageable than the inches. It's a lot bigger of numbers. So we want to take just these, the basic, the plane design and the feet. We showed them how to highlight, go to insert. Now there's all these tables. Some kids want to do lines and pies and all that, but really what makes the most sense is a bar graph that is horizontal, that shows their average feet here. So one thing we always point out, especially teaching science, math, or engineering, whatever, when you make a chart, you need to include axis titles. So putting the axis titles on here and a legend, just so we know, so that the blue lines are average feet. On the axis title, get that to highlight finally. For this one, it is plane designs, and I would actually be having these students, I would walk them through the steps, and then they would do this themselves. So there's plane designs on the y-axis. The x-axis is average distance in feet. Got it. And then for the title, we'd have them come up with this. So some students had average flight distance in feet. There's this hidden there. Okay, that deleted some of that. So average flight distance in feet. So we would have this, and they could understand the basics of graphing. We can see now visually, not just with numbers, that the types of dynes, so the stable and the dart, both have much longer flight endurance times here, flight distances. As I saw, the stable is aerobatic, but it's also time of flight, according to our website here, time aloft. And the dart is a distance type of plane. So the students can see this, they visualize this, and they prep this as part of in their notebooks so they keep this data. The next step would be the next class is to then take this information, again, look at the planes, and then see what can be done to improve the distance of these planes, such as make sharper creases or make thicker wings to potentially produce more lift. Maybe bend the ends up to make a little stabilizer, or don't bend the corners as much in the tail spin because it just makes it spin in a spiral. So they could do lots of those little tweaks to keep the design the same, but just make small changes. And then they would do the same testing the next day. And again, complete another data table here, another graph to see what those changes were and test those variables. I hope this was a good lesson, a good example. Again, this can be used for just about any grade level. You can simplify it. You can do it with just one paper airplane design. You can do it with at least 3 tests to get an average, and up to 20, 30, 50, 100. To any level you want to take this. Like I said, this could be a basic introductory lesson all the way to a type of science fair type of project, depending on how in-depth you want to get with this. But this is a good one I like to use with math to review basic data collection and review and averaging and all that. So thank you very much. Have a great day.